The sun is not on fire. Fire needs fuel, and it needs oxygen. There is no oxygen out there to speak of, and if the sun were burning in the ordinary sense, it would have gone out a long time ago. A ball of coal, that size, burning lasts a few thousand years. The sun has been shining for 4.5 billion. What it does instead happens only in the very middle. The core is squeezed by the weight of everything above it to a density around 150 times that of water and heated to about 15 million degrees. Under those conditions, hydrogen nuclei fuse into helium, and a small part of the mass becomes energy. Here is the part that surprises people. The core is not violent per unit of space. Averaged over its volume, it produces something like 270 watts per cubic meter. A compost heap gives off heat at a comparable rate. The sun is enormous, not intense. It works because there is an unimaginable amount of it, all doing something quite gentle at once, under a weight nothing on Earth can imitate. We know the numbers because the physics of fusion is testable in laboratories, and because the sun's own vibrations tell us the density and temperature inside. Both of those are on this list further down. The sun is white. If you go above the atmosphere and look at the sun, it is white. Not pale yellow, not gold. White. The surface we see, the photosphere, sits at about 5,700 degrees. And at that temperature it gives off light right across the visible range, with no color strongly favored. Mixed together, that is white by definition. Our eyes are calibrated to this star, so the light it makes is the thing we call colorless. The yellow is the air. Our atmosphere scatters short wavelengths more than long ones, so blue light gets bounced sideways across the whole sky, which is why the sky is blue. What is missing from that blue is missing from the disk, and the disk looks warmer than it is. At sunset, the effect goes much further. The light is coming in at a shallow angle through a great deal more air, so more of the blue is taken out, and what is left is orange and red. Every photograph of the sun you have seen is a decision. It is far too bright to photograph honestly, so it is filtered, and the filter chooses the color. Pictures of it as an orange ball with dark spots are images taken in one narrow band of light and colored afterwards, usually for clarity rather than beauty. Sunspots are not dark. A sunspot looks like a hole. It is not. It is a patch of the surface that is somewhat cooler than everything around it, and it only looks black by contrast. The surface is about 5,700 degrees. A spot is around 4,000. If you could cut a large sunspot out and hang it in the sky by itself, it would be brighter than the full moon and would glow orange. They are cool because of magnetism. The sun's outer third churns, carrying heat up from below the way a pot of soup does. Where the magnetic field bunches into a strong bundle and breaks through the surface, it stiffens the plasma and slows that churning down, so less heat arrives at that spot. The field there can be thousands of times stronger than the Earth's. Large ones are wider than this planet. They have been recorded by naked eye through haze and smoke for well over 2,000 years in Chinese records, and they have been watched through telescopes without a break since 1610. That unbroken record is one of the most valuable data sets in astronomy, and it is how the 11-year rhythm on this list was found.